Hello everyone. In this exercise of the SolidWorks, we will create. We will find the how to. We will create a pipe chair in the weldment, and then we will calculate the factor of safety for this structure, and also see the stress analysis of it. Let's start. File, new, part, and this one. This part default option. This is the part model. Okay. This is the SolidWorks user interface and sketch. I am selecting the plain white, and this is the plain white, and the unit system is this millimeter gram second. Okay. In this exercise, we will calculate the factor of safety for a steel pipe for a chair consists of the pipe. So, and we'll see the also the stress analysis for that. So first we will create a structure for the chair. I am selecting the front plane. I am selecting the sketch 3D sketch. With the help of the 3D sketch, we will make a pipe chair structure. Take a line, this one, point select. In the 3D sketch, the sketch, the direction in which you want to draw the sketch, the arrow must come. If arrow comes, then it means you are on the right path. And you see, because arrow is coming, so I am moving in the arrow direction, and the arrow direction, and if you see this dotted line, it means you are on the right path, and then you click where you want the desired length. Okay, I am clicking here. Now backward, because arrow is coming, so I am moving along arrow direction, and this dotted line appears, it means I am on the right path. Click. Now this arrow is coming, I am moving along the arrow direction, and when you see this dotted line, it means you are on the right path. Okay, this one. Now I am moving in this direction, but arrow is not coming, so I will press the tab key in this direction, and now you see that this dotted line, it means you are on the right path. When you see this dotted line, it means you are on the right path, and you click where you want to click. Okay, this one. Now I am moving this, arrow is not coming, then again press tab key, then arrow is coming, I am moving in the arrow direction, and you see that this dotted line appears, it means you are on the right path. Click there. Okay, now I am moving up, but arrow is not coming, press the tab key. Okay, now arrow is coming, I am moving along the arrow direction, and you see the dotted line appears, and click there. Okay, this, click here. Now I will move in this direction, arrow is coming, I am moving along the arrow direction, and the dotted line comes, it means you are on the right path. Okay, and click. Now arrow is coming, I am moving in this direction, this one, and dotted line appears, it means I am on the right path. Click there. And I am moving, I want to move in this direction, but arrow is not coming, press tab key, and this one, arrow is coming in this direction, whether it is backward or forward, no material, no problem. And when you see this dotted line, it means you are on the right path. This dotted line appears. Now you are seeing on the screen this one, and click. Now and join last point. This I am making the structure for a chair. Okay, I am joining this point, last point, this one. Okay, now I will make certain relation. First select this point and shift key this point. This is along z direction, this z direction. Okay, okay, and this, click this point, shift this point along z direction, this one. Okay, now press this and this along z direction. Okay, now press this point and shift key this point along z direction. Okay, and this line along x direction. This is along x axis. Press along x axis. Okay. Okay. Now this line along y direction. This is, you see, y direction. This one. This line and along y axis. This one. This way. This one. Now we give the dimension. This dimension I am taking 400 mm. Okay. This direction I am taking 400 mm. This direction I am taking 400 mm. This dimension I am taking 400 mm. And this dimension I am taking 400. All the dimensions I am taking 400. Sketch is fully defined, but I am taking the fillet at the corners. Fillet I am taking 50 mm fillet. This point, 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 and this point. This is 50 mm fillet. This one, okay, hit the right button and cancel it. This one, this is the structure for the steel pipe chair. Okay, press out, and in the weldment structure member, I am taking ISO standard pipe, and this pipe size is 33.7 into 4. This one groove. This one, because this is not continuous line, I am selecting this, and this is not a continuous line. Okay, this one, I am making the steel structure for a chair. This one, I will not make a complete chair, but I will make the metal part. This one, this and this, and this one, and this one. This is a pipe. This one. This is the shear structure. Okay, and 3D sketch, hide it. Now it becomes clear. Future and isometric. This one, diametric, trimetric. Okay, this one you can take this one. Now in the simulation, this simulation tab. This is simulation tab. Tabs, and this is the simulation not coming here. This is the simulation. Okay, if this tab is not coming in the tab section, you can go in this one and add-ins, and from here SolidWorks simulation you can check it, and okay, then it will come in the tab section. Okay, now press simulation, and there you find the new study. When click this scrolling arrow, there is a new study and simulation advisor. This simulation advisor system advises the user to how to use this study. Okay, but I know the simulation setup, so I go in the new study. In the static means we have to fix certain part of the structure so that body could not move. That's why this is known as static study. Static study, I give the name chair, static chair. So for example, this one. Okay. This is the name of the part. The static chair simulation parts. Firstly, we have to prepare the model, which I have made here. Okay. Now I apply the material to all bodies. This one. I am using ASI 304. Yield strength is this one, 20680 Newton per meter square, and tensile. We are mainly concerned with this thing. Okay. Apply and close. This is the steel section. Okay. There are different, you will see the cut list is this one. There are the different cut list pipe, this one and this one. So I have applied. If you see the tick mark is here, it means I have applied all the marks. When you see the tick mark, it means material has been applied here. Okay. Now connection, because we have the single part, not assembly, so there is no need of connection here. Okay, connection we use in the case of assembly of the parts. Okay, picture, right click, fix geometry. Firstly, we fix certain part of the structure, steel structure, so that it could not move in order to make this structure stable. That's why this is known as a static study. So joint, I select this one, this joint, this joint, this joint. Because this position rests on the ground, so that I am fixing this. I am fixing this part because this is in touch with the ground. Okay, this one, this joint. Now next is the external load. External load, right click, apply force here. Force, and I am selecting the other different option where you can apply the force. This is a beam in the weldments. This I am selecting beam, select here this beam, this acts as a beam, and this is the direction. Direction, how can you select? You will see direction, but can we take face, edge, plane for the direction. Okay, this right show the sketch. So I am selecting this direction. Okay, and pipe and the unit force unit is I am taking a SI system, and the unit force is I am taking 1000 Newton. Okay, suppose person is sitting of a 1000 Newton weight. Okay, actually weight is equal to mass into gravity. Mass, suppose 100 is the mass of a suppose a certain person. If you multiply into 9.8, 9.8 is approximately equal to 10. It means 1000 Newton weight will be the of that body. Okay, this one, and apply it. Direction, you can change the direction from here. Edit definition, you can change, reverse the direction. This is the force direction. You can reverse here. I am keeping the force downward direction. Okay, this one. This is a force applied. Mesh. In mesh, right click, create mesh. This one. The mesh is applied. Mesh, actually this part structure is distributed uniformly with the finite elements. Okay, you want to see the details of this one, you can mesh details you can see here. This is the details of the mesh. It consists of the elements and the nodes. Okay, this one you can, this one detail it. Now mesh have applied. Run in the command manager. You will, in the simulation section, you will find run this study. Estimation calculation work takes place, and this text appears here. Okay, now you see the stress is this one. Stress is 8.3 into e raised to the power 10. E means 10 raised to the power. Okay, yield strength is the dead strength, which a part component of that with that material can bear the load without deformation. This is that strength. Yield strength means component can bear up to this load without deformation. This is the yield strength. Okay, this one. But this is very high. If you see deformation scale is 11.14. Suppose this stress value, right click and a chart option and a definition, and this is an automatic scale. Automatic scale is the very at elevated scale, 11 point something. But I am taking the true scale. True scale means unit scale, or you can take user defined. At what scale the customer want to see the stresses, you can assign that value here. But I am taking true scale. True scale means actual scale, unit scale, and the unit I want to change is that is Newton per millimeter square, that is megapascal. 1 Newton per millimeter square is equal to 1 megapascal. Okay, and this one. Okay, you want to animate stress, animate. You can see this. This is the scale. From here you can allow give the frame value here, this one, this, and speed you can also increase of this one, and start. You can see this. This is the stress value. You can see in this way, and so this value, our yield strength is 2.068 into 10 raised to 2, and maximum stress is this one. Maximum is this one. Minimum is 0. So 8.331, which is less than yield strength value. It means our structure is safe up to this, up to the 1000 Newton load for this one. Suppose you want to see the maximum and minimum stress, right click chart option, and you can see show minimum and maximum annotation, this one. So this is maximum annotation 8.31 into 10⁻⁴. This is the Newton per millimeter square maximum stress is there, and this is the minimum stress. You can see the maximum and minimum stress. Okay. Display in the same way, displacement also you can see, double click, this is the displacement value. Okay. And displacement value, deformation in the same way you can chart option and definition you can, this is this scale 11.14, this one automatics, but I want to true scale or the 1 millimeter, value is millimeter, and chart option is here. Chart option is here. You show minimum and maximum, and this one, and you can see animate here. This one, this is animation. You can increase the frame rate 9, calculate suppose 15, and you can increase the speed here. You can save also as AV file. You can save from here. Okay, and you start this one. This is the displacement value. Displacement value. This is showing this one. Maximum is 8.91. E means 10 raised to the power. 1 point this is this one. In this way we can calculate the displacement. But our main purpose is to find out the factor of safety in the command manager. You can apply the material from here. Apply material, fixture advice, fixture geometry, external load you can apply from here also. Connection advisor, and now in RELT advisor you can go, and here there is the new plot and factor of safety. This is the factor of safety. Okay, you click press in the left side, there a window appears, next, and factor of safety, this one. You see factor of safety distribution is equal to 2.5. It factor of safety must be always more than 1. It means our product will be safe. Not equal to 1, but it must be equal to 1 for the in order to avoid the failure, but it should be more than 1. That's for example 2.5. It should be also more than 1. Factor of safety is minimum FOS 2.5 means if I calculate, I have applied the load of 1000 Newton, 1000 into 2.5. I multiply this value. It means 2500 Newton load. This chair can bear without deformation. Okay, and in this way you can find the factor of safety for this. And suppose you want to, this is the factor of safety, and suppose this stress, right click, edit definition, chart option. In chart option you can, this color chart is there. You can change the value of this one, floating. Suppose you want to change, this value in this one, and this is the journal. This way you can also change the customize this section also. Color option, you can add the color, default color is this one, and specify color above yield strength. This is our yield strength. Yield strength is this one. You can mark where the yield strength changes the stress value beyond the yield strength. You can assign the color from. You can also customize this one. This is the plot subtitle also. Okay, this is the plot subtitle also. You can change from here, simulation option. This is the chart appears, system option. You can increase the plot size. Suppose you want to. This is the plot subtitle in left hand side where my cursor is here. Suppose you want to change the let font size, font regular, etc., and change the sage. Okay, and this okay. This one, this is the plot subtitle. You can increase this size. Also, this you can increase this one. Simulation option, and this is the plot subtitle, color chart. Color chart you can also increase 16 mm, 18 mm. You can increase this one, and okay, this one. In this way, you can also customize this section also. I hope you would have enjoyed in this exercise. you please like, share and subscribe my this channel, and please subscribe my this channel for to get more videos, and thank you very much.